real this time. Greetings and welcome. Today we're talking about factoring special patterns. Have you ever factored like a polynomial and then ended up with maybe some conjugates when you factored it and you're like, there's got to be a better way? That's exactly what I've got for you today. It turns out you factored a pattern and you didn't know it. That's true. Wow. The things we learn. Let's see. This is called the difference of squares pattern. Difference of squares. And if you could memorize this, this would be amazing. It would help you out. It'd make your life a lot easier. The difference of squares pattern is a squared minus b squared. And what is this equal to when it's factored?
C squared. Nazi squared.
Nazis squared. No. I see what you did there, though. If it was a squared plus b squared, that's equal to c squared. If you were Pythagoras, we'll talk about him someday. But a squared minus b squared is equal to a plus b times a minus b. We've seen this pattern before. I just presented it to you in the reverse order. And I probably called it the sum and difference pattern. Right? Where back when we were multiplying polynomials, I showed you this and I said, hey, you could shortcut and just write it that way. Now we're doing the opposite of multiplying, where I'm factoring. So it's actually beneficial to know this pattern in reverse. So let's do an example of this. Exemple. Let's say I had this example, 16x squared minus 169. This is kind of like a problem from homework that we just did in the previous video. So when I look at this, first of all, it's a two-termed expression. When I see only a binomial that I'm trying to factor, the first thing I consider is, can I yoink yoink? And the answer here is no. Sadly, these are relatively prime terms. There's nothing they have in common. I can't steal something from both of them. The second thing I consider is this difference of squares pattern, meaning, could this possibly have been a perfect square, and could this have been a perfect square? So what squared is 16?
4.
And what squared would be x squared? X. And what squared is 169? 13. So it appears as though these are two perfect squares. They're being differenced. No, subtracted would probably be a more appropriate word. So therefore it matches this pattern. So I'm going to say that A in this pattern is equal to 4x. And B is equal to the 13. And now all I do is just plug it in the pattern. So A plus B, so that's going to be what? 4x minus 13 times A minus B. Oh, that was a plus sign. Times A minus B, so 4x minus 13. And there we go. It's nice and factored.
What?
I didn't have to do any work, really. I just had to recognize that it matched a pattern. And I could take this awesome shortcut.
That'd be cool.
Yeah, shortcut.
Oh boy.
What if we did like 16x squared minus 160?
Wouldn't that be disappointing? Because then you'd be like, oh, it was so close to being a perfect square. But it wasn't, and then that would mean that it would be either factorable some other way or just maybe not factorable at all, and that would be prime. So, but yeah, so that's the point. This pattern only works when these happen to be perfect squares. Actually, what do I mean by perfect squares? Do you guys know the list of perfect squares?
Yeah, we do it, but I forgot it.
Here's perfect squares. All right here.
Yes, I love
1
it.
is a perfect square. 4, 2 squared is 4. 3 squared is 9. 4 squared is 16. 25. 36. 49. 64. 81. 100. 121. 144, etc. There's infinitely many of them, but chances are the ones we're working with are small in nature. And then 169 happens to be 13 squared, which is the next one in that list. Right? So perfect squares is good stuff to know. So when I notice numbers that seem perfect, then I'm suspicious of the potential of a pattern existing. Am I right? Am I right? Now, here's another example. How about, what if I had What if I had this? X squared minus, let's do 9y squared. Ooh, so this one's interesting. It's actually got two variables within it, but that's okay. Quite all right. Now, I'm suspicious of this being a perfect square difference of squares, right?
I think it
Is
is.
it?
No.
Let's see. So we could start with this little setup of could I rewrite it as the difference of two squares? You don't have to write that step every time. I would trust that you could just write a equals b equals. But let's see. What squared is x squared? X, right? Or even if you really wanted, you could write 1x. But 1 is a perfect square, right? And what squared is 9?
3.
3. What squared is y squared? Y. So a is equal to x, b is equal to 3y. And then I can fill in the pattern. So x plus 3y times x minus 3y. Done. All right? Done. So much easier than I had in the last video. Now, one thing I want to point out. Here's a not pattern. Okay? Not pattern, right? There is no such thing as the sum of two squares pattern. Okay? No such thing. So even if you have two perfect squares, if there's a plus sign in between them, too bad. C squared. I like it. I like it. I like it. So there's no way I can factor the sum of two squares pattern. It just don't exist. It can't. The reason is I'd be trying to find the factors of b that add to be 0, and I can't have two positive numbers or two negative numbers that add to be 0. It just doesn't work, right? Just can't be done. Can't be done. So there's no such pattern for that. Now, how about a couple other patterns I can give you? What about this one here? Actually, I'll write this down. This is called the perfect square trinomial pattern. Perfect square. Hey, whoa. Trinomial. All right, perfect square trinomial. What's that look like? We've seen it before. A squared plus 2ab plus b squared. What's that done there equal to?
Oh,
A squared plus, no, a plus b all squared.
Perfect. A plus b all squared. So we saw this side before. This name we called the square of a binomial. And when we expanded it out, we had this pattern. And now it's exactly the same patterns we had before. It's just I've flipped them around. We're looking at it from the different perspective. There's also the variation of this pattern where if this was a minus sign, then this is a minus sign. So bam, you just memorized another pattern with very little effort. You just had to know like two locations of possible minus signs. Am I right? Am I right? I'm right.
right.
I'm pretty sure I'm right. So here we go. Let's do an example. Example. Here we go. Examples. So here we go. Here we go. What if I've got x squared minus 10x plus 25? All right? So looking at this, you might just be like, all right, I can't GCF nothing. I'm going to go find factors of C that add to B. And then you'd like get moving and cruising right along, and you'd factor this. It wouldn't be terribly difficult. But I'm suspicious this matches a pattern. What makes me suspicious? What makes me think that this could be a pattern? Well, this appears to be a perfect square, and this appears to be a perfect square. Right? You guys agree?
Yeah.
And because of that, that is enough reason for me to begin investigating whether or not it matches the pattern fully. Now, it's possible, maybe it doesn't match the middle. Maybe it doesn't match the pattern fully. But this is somewhere to start. And my first clue is I saw some perfect squares. So let's do that. So what would A be and what would B be? BB? BB. What would A have been in this? A would just be the x, right? Because I'm matching it up to this. What squared is x squared? X, right? And what would B have been? 5, because 5 squared is 25. Now the question is, before I can commit to this being a pattern, my question is negative 2ab equal to negative 10x? That is the question. So question mark. There's a good question mark right there. So negative 2 times a, which I just defined as x, and times b, which I just defined as 5, is equal to negative 10x. So it works out. So it matches the pattern. So because it matched all 3 components of this pattern, okay? It has to match all 3. Now I can just plug it into this. And it's going to be super awesome. So this one's going to, is this going to be an A plus B or an A minus B? A minus B. So this is x minus 5 all squared. Yeah, no es más mal, right?
It's not very bad.
Yeah.
God.
It's okay. This is math class. It's not Spanish.
No.
All right, how about this one, friends, friendos, amigos, compadres? What if I've got this? What if I've got 3x squared plus 48x? Let's see. Oh dear, did I mess myself up here? Oh dear. Plus 172. I think I've got this. I think I've got it. So, looking at this, does this appear to match a pattern? Is 3 a perfect square? No. Is 172 a perfect square? No. So I could jump in and start AC methoding this, but wait. The first thing we should always consider, can I do a little bit of a yoink, a yoink, a yoink?
No one likes that.
Yeah.
Everybody likes that. Come on now. I could steal a 3 out of these guys.
That's it.
3 times x squared plus 16x plus 64, if I'm not mistaken. Hopefully my mathematics work. Let me verify. No, I lied. Darn it. Yeah, 172. That wouldn't work. Let's see, 64 times 3. Tell you what, let's pretend, what if this was 192 the whole time and no one ever knew? What? What? Now, oh, guys, classic, of course. Yeah, you factor 3 out of those things. Apparently when I was trying to do 3 times 64 in my head, I messed up. I did 3 times 6, 180, and then I just messed up on that one digit. My bad. Hey, I'm human, guys. My apologies. There you go. Now, guys, looking at this, am I done factoring this? This is not a boxable answer. It turns out the inside of these parentheses, I could go a little bit further. Let's go all the way. Actually, in fact, this looks like a perfect square, and this looks like a perfect square. And actually, 16 is a perfect square as well. X isn't, but the middle doesn't matter to us at this point. So what would A have been? X. And B would have been 8. Okay, yep. And is positive, because this is a plus sign, is 2AB equal to 16x. So 2 times x times 8 is 16x. It worked! It worked! So it matched the pattern fully. So what do I got? I've got this 3 is still hanging out on the outside. That's not going anywhere. And is this going to be an a plus b squared or an a minus b squared? Plus, because of this plus sign there. So a was x, b was 8. Throw that plus sign. Wha-bam. Awesome sauce. The 3 is just hanging out. It's just being multiplied. Right? Well, no, we can't. For factoring, we're trying to write it as the product of as many expressions as we can, breaking those down as far as possible. And 3 times something, that is a product, so I wouldn't want to try to distribute it within this. And in fact, I actually couldn't, because I'd have to deal with the squaring first before I distribute. I mean, technically, I could also write that as 3 times x plus 8 times x plus 8, both in parentheses, but we like consolidating it down into a simpler form. Let's see. I think I'm going to do it, guys.
No.
I've got one more pattern for us.
Why do you do this?
This will be the sum or difference of cubes pattern. Cubes. This is like Minecraft. You guys will love it. Kids love these things, right? Cubes. You guys love cubes. Ice cubes, sugar cubes, Minecraft cubes. Legos are cube-like, but not. They've got a little peg on top, and they're not actually cubes. They're more of rectangular prisms now that I think about it. It's amazing, but don't worry about it.
It's a stupid little weird game. It's all pixelated and gross.
All right, friends. Let's focus here. We'll save it for the Minecraft seminar later this month. Minecon. Actually, that's not this month anyway, but I wouldn't think so. But anyways, a cubed plus b cubed. Ready for this? This fact is factorable. Now, I told you a moment ago there's no such thing as the sum of 2 squares pattern. There's no such thing as that. There is a sum of cubes pattern. And actually, there's also a difference of cubes, which I'll show you in a moment. But a cubed plus b cubed factors to be a, ready? A plus b times a squared minus ab plus b squared.
Why?
It's just the pattern.
Why'd you do that?
I mean, we could multiply this out and verify that it works if you really want. You want to, or?
Maybe tomorrow.
Let's do it.
I'll do it tomorrow.
Alright.
We'll figure it out. And it turns out, ready for this? This pattern's not that different if I put a minus sign here. This will be a minus sign. And then this minus sign will become a plus sign. All right, so it's a little bit of a switcheroo on us there, but not too bad. Also, notice how similar this is to our perfect square trinomial pattern.
It's close.
It's really similar. What's the only thing it's missing? The 2, right? If there was a 2 here, then this would actually be able to factor even further. But there isn't. All right? So that's the sum and difference of cubes pattern. Whoop, 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 whoop. And before I go any further, what are the perfect cubes? What are some perfect cubes?
9.
No, 1 cubed. 1 times 1 times 1 is 1. Okay. 2 times 2 is 4, times another 2 is 8. 3 times 3 is 9, times another 3 is 27. Okay, 4 times 4 is 16, times 4, 64. 64 is actually, 64 and 1 so far are both perfect squares and perfect cubes. Hey, what do you know? Let's see, 5 times 5 is 25, times another 5 is 125. Let's see, 6 I probably don't, I think it's 216. 6 times 6 is 36. 36 times another 6 I believe is 216. Oh yeah. And then let's see, 7 cubed is 343, and so on.
What?
So those are the perfect cubes I'm talking about. Now let's talk about this example. What if I've got, ready for this, 8x cubed minus, ooh, I could be devious. How about y
Why?
to the 6th?
Why are you doing that?
Am I right? So check this out. First of all, I'm suspicious that it matches this pattern. Is the first term a perfect cube?
Yes. Yes.
Let's see. If you want, you could write it this way if you'd like. What cubed is 8? And what cubed is x cubed? Okay. How about the second term, though? Y squared cubed is y to the 6th. Craziness! Am I right? A equals 2x. B equals y squared. Let's just plug it into this pattern. So that's going to be a plus b, so that's 2x plus y squared, times a squared, so that's 2x all squared, minus ab, so that's 2x times y squared, plus b squared, so y squared squared. Throw your hands in the air like you just don't square. Here we go. 2x plus y squared. Let's see. This and then that. Yeah. Let's see. 2x all squared. What's that going to be? 4x squared. That 2 is included in that square, right? So, minus, let's see, this doesn't simplify much, minus 2xy squared. And then plus, y squared squared is y to the 4th.
Yeah.
I like it. I like it a lot. Wow.
Why is it gonna do like that?
I don't like that at all. I'm trying to get rid of that.
Cubes are stupid.
Cubes are stupid. What?
Square
What?
cubes are-
Actually, funny thing, I guess it's a bit of a stereotype, but I'm Finnish. Finns, when they drank their coffee, they used to actually take a sugar cube and stuff it right up in the corner of their mouth and then not put any sugar in the coffee, right? So then they drink the coffee, and the coffee and the moisture and the heat would slowly dissolve that sugar cube, and like that's what they would do. They'd just keep the sugar cube right in their mouth the whole time. The Finns, Finnish people, Finland, Laplanders even. Laplanders are technically Finnish people who live above the Arctic Circle, but seriously, what kind of Venn diagram would that look like? That would be like a circle and then like the shape of Finland and then the cross section between the two. That'd be a pretty awesome Venn diagram, actually, now that I think about it. But anyways, but no, as a result, many of the old-timer Finns have like one tooth that's all like blacked out because the sugar was just always touching
I
it.
want to say I should try that.
Yeah.
After hearing that.
Yeah, not recommended. I imagine you could also lose that tooth at some point. But then you can just replace it with a sugar cube.
I don't have that.
It's like your sugar cube slot, right? Okay, last question. What if I have... What if I have x to the 4th minus... Let's see. Let's see. What was I going to do? I'll just do this. X to the 4th minus y to the 4th. Now, what patterns so far do we have that this could match?
Perfect
The perfect
squares.
Perfect squares! Yeah, I don't have a perfect fourths formula, but I imagine we could generate one if we wanted.
So x times
So what squared minus what squared?
x squared and y squared.
X squared squared and y squared squared. I like it. So A is x squared. B is y squared. Okay, so let's plug it in the pattern. Which pattern is this equal to?
Squared squared.
Oh, it's
A.
squared.
Nope.
A negative 2ab.
Nope.
That was not.
A plus B squared.
Nope.
A plus b all squared.
Nope.
What?
A plus B times A minus B. So here we go. X squared plus y squared times x squared minus y squared. Are we done?
We're done.
We are not done. Why?
What?
One of these is further factorable. Is this factorable?
No.
Why?
Because you can add.
Because there's no sum of two squares pattern. This is factorable. This actually matches the same pattern that one matched. What? So in this case, what would A have equaled and B have equaled? Just X and Y. So guys, I had like a pattern within a pattern. This is like Inception here. What? Did you just see that? So this guy, instead of writing x squared minus y squared, is the same as a plus b times a minus b. So that's x plus y times x minus y. Yeah. That is pretty sweet. So I just want to point out, sometimes you can factor things further than you originally thought. Well, we'll do plenty of practice. Don't you worry, friend. All right, bye-bye, friends. Bye-bye.